Hello everybody. So for this next section, we're going to talk about two different types of congruency theorems that we can use to prove that two different triangles are congruent. Okay, and hopefully you guys remember by now, and especially emphasizing what we learned in the previous section, that the meaning of congruence means that they have the same values. In this case, if we want to prove that these two triangles are congruent, then we're saying that all of their sides, or that they have three of the same lengths of sides and three of the same measure for angles. Okay, so sometimes you'll see in like a lot of these proofs that you have to prove that, like, for example, these two triangles are congruent. Even though they're not in the same orientation as these two triangles, there's still a series of ways that we can go ahead and fill in these blanks and use a lot of these other theorems that we know to prove that these two are the same values, right, or congruent. All right, so the first theorem we're going to learn about is the side-side-side theorem. All right, so essentially what the side-side-side theorem is telling you is that if three sides of one triangle are congruent to three sides of another triangle, then both of these triangles are congruent. So that's pretty much all you would need to prove that those two triangles are congruent. So let's say we had this triangle here, A, B, and C. C down here. And then we have a completely different triangle. We'll say this is triangle E, D, and F, right? So if through my series of steps, I can prove that this side is the same as that side. So if I know that AB is not the same, but the same value as that side, or congruent to ED. And then if I can prove that this side is congruent to that side, so BC is congruent to DF. And finally, that this side is congruent to that side, AC is congruent to EF, right? If I can prove that these two triangles have three congruent sides, then I can pretty much prove that triangle ABC is congruent. And I want to make sure that the letters are in the same order. Like if A is congruent to E and B is congruent to D, put them in the same order as you would when you write out your triangle. So EDF. All right. That's one of the theorems we're going to learn about. Another theorem we can talk about is the side-angle-side theorem. Now, something I want you to understand is that, first of all, if I want to use this theorem to prove that two triangles are congruent, I have to make sure that the side and the angle and this side, angle, and this side, that they're right next to each other, right? I can't use, for example, like S, and then like an A over here, right? Or like say that this side, then this angle, and then this side all the way over here, skipping this angle is the one. No. The only way that the side-angle-side theorem works is if the side and the angle and this side are congruent to each other like that, right? Or they're congruent in that format, all right? So for example, let's use the same letters again. If I have A, B, and then C, and then this is E, F, no, I said this one was D and then F, right? So for example, if I can prove that that this side AB is congruent to ED, right? So side AB is congruent to ED. And then I can say that angle B is congruent to angle D. This is the D, right? And I can go prove that angle B, or that side BC is congruent to side DF, right? If all I have are these three known values, then that's enough for me to say that triangle ABC is congruent to triangle EDF, right? So we're going to go ahead and prove this with a series of, we're going to use, and we're going to be nice enough, we're going to give you all of these different theorems that you can use to fill in the boxes below. So let's just kind of get into the first example. The first example is saying that they have JL is congruent to MN. So they're saying JL, so I'm going to go ahead and mark that. So JL is congruent to MN, right? So we took care of that. And then we know that K is the midpoint of JN and LM. So I know that K right here, this is the midpoint. All right? So we're going to have to somehow prove that triangle JKL is congruent to NMK. I mean, sure, they look like each other, but it's not enough to just look at this and say, oh, well, this triangle looks like that one, so that I'm going to go ahead and say that they're the congruent triangles. No, in geometry, at least in this class, we have to make sure that we prove it by giving them all these reasons why. And on the left side, we're going to go ahead and provide you with some of the steps that we use, but you have to tell us the reason why these steps work. So first of all, they say that JL is congruent to MN. Well, that was part of our given statement, so that part was easy. Then they say that K is the midpoint of JN and LM. Yep, that was also given to us. And just as usual, when you start a proof statement, you're going to go ahead and write out your givens first. Now this one is saying that JK, so they're saying JK is congruent to KN, right? So now you got to think to yourself, why is that true? Well, if you think about it, point K is in the middle of those two, and by definition of a midpoint, then those two sides would pretty much be the same value. So we can go ahead and justify this by saying definition of a midpoint. All right. Now they're also saying that LK is congruent to KM, so two different, completely different sides, and they're both congruent to each other. Again, if K is the midpoint of all of, of these two different lines, well, then we can pretty much use the same justification as to why those two sides are congruent. So we have the definition of a midpoint again. All right. So we already went ahead and proved that we have three different congruent sides that are similar to each other. So now they're saying, okay, well, don't we have enough proof that these three triangles are congruent to each other? So they're saying triangle JKL is congruent to NKM. And we know that because we have three different sides that are all congruent to each other. So therefore we proved it with side, side, side. Okay. So that one wasn't too difficult to work with. Now, let's look at example 2. It says given that AB, so they're saying AB is congruent to BC. So this side is congruent to that side. And then they say that BD bisects angle ABC. So we have angle ABC. So essentially, this line right here bisected that. And hopefully you guys remember that bisect means cuts in half. Okay? So if this line bisected that, then wouldn't that tell us that this angle and this angle are pretty much the same value? Yeah, that's if you cut something in half, kind of like a midpoint cuts a line in half, then those two have the same value. All right, so now they want us to prove that triangle ABD is congruent to triangle CBD. So let's go ahead and look at the statements that they have and kind of justify it ourselves. So they say that AB is congruent to BC. Well, that was given to us, so that part was simple. Then this one says that BD bisects, and that was also given to us. All right. Now they say that angle ABD is congruent to angle CBD, right? So they're saying that angle ABD, so this angle is congruent to angle CBD. So both of these angles are congruent. Well, what's the reason for that, right? And again, this is where you're gonna have to get to the point where you can remember all of these rules. And if we are, the justification we're gonna use is because this line right here went ahead and cut that in half because it's the angle bisector. And by definition of an angle bisector, it is going to cut that angle in half. So we're just gonna go ahead and say definition of angle bisector. Okay? Now if we look over here, well, it says that BD is the same thing as BD. Well, I mean, obviously, aren't they the same segment? And if you kind of think about it, like if I broke this triangle apart, right? I have BD here and BD here, right? Obviously, if they're both BD, then that's gonna take on the same value as that, right? And again, this is just something that you have to remember but that's a definition of reflexive property. The definition being that a side is congruent to itself. So based on the reflexive property, then we know that BD is congruent to BD. So we have reflexive property. And then finally we have triangle ABD is congruent to triangle CBD. So let me kind of look back at this triangle. We already said that this side was congruent to that side, and this angle is congruent to that angle. This one being A and this one being C. So right there, if you notice, right next to each other, we have a side and an angle and a side next to each other that are kind of congruent to the other triangle. So based off of that, we can go ahead and justify that they're congruent by side, angle, side. Okay? Finally, let's look at example 3. It says, given that AC is congruent to AD, so here we have AC is congruent, we can't really see the D, but it's right there. AC is congruent to AD, and CB is congruent to BD, all right? Well, I mean, we already have two sides that are congruent. Somehow we can prove that an angle is congruent to another, or another side is congruent. We might be able to get somewhere with this. But it says here to prove the triangle ABC is congruent to triangle ABD, right? So this time we don't really have that much to work with, but we can kind of fill this in ourselves. We said, first of all, they gave us that AC was congruent to AD, right? So that's given to us. Okay. We also know that CB is congruent to BD, which is another given that we have. So we know that CB is congruent to BD. All right, so what else can we use here? Now we're gonna have to kind of figure this out ourselves. What else can we use here to prove that these two triangles are congruent? So I'm kind of looking at this and I'm noticing that this is the third side of both of those triangles. And if both of these sides for both of those triangles AB, well, wouldn't AB for one triangle be the same value as AB for the other triangle? I mean, they're both AB, right? So there you have those two are the same. Like if I broke these triangles apart, right? It's the best I can do, but AB and AB is going to be congruent to itself, right? So right there, if we have the other sides of the triangles that are congruent, then we pretty much prove that triangle ABC is congruent to triangle ABD, right? Well, I should have finished this proof, but remember, proving that a segment is congruent to itself is the definition of reflexive property, right? And we just proved that three different sides are congruent to each other, so we proved that the two triangles are congruent by the side theorem. All right, so hopefully that video was helpful. Hopefully that gives you somewhat of an understanding of how you can prove that two triangles are congruent based off of that theorem. So if you need any help with this, you can always ask any of us, and we'll be able to help you in any way, shape, and form. Good luck.